In this video, we solve problem 8.1.508.xp from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to find the area of region, and then we're asked to round our answer to 4 decimal places. And we're told that this function is given by y equals x times the square root of 8 minus 2x squared. Well, first of all, we have to remember this from Calculus 1, that if I want the area between a function that is positive on the interval from x equals a to x equals b, all I have to do is evaluate the integral from a to b of f of x. Oops. So that area is equal to this. So when they're asking us for this area, what they're really asking us for is to, first of all, connect this idea to this idea, that the area under this curve is actually the integral from x equals 0 to x equals 2 of this function. And then they want us to evaluate that integral. So we'll start by doing that. We start at x equals 0, we go to x equals 2. F of x in this case is x times the square root of 8 minus 2x squared. And we're taking the integral with respect to x. And when we're done, that's going to give us an area. And then we'll want to use a calculator to approximate that area to 4 decimal places. So let's start by looking at this integral and asking ourselves whether basic rules apply. You just ask yourself, do I have a rule for that? And we don't have a rule for that. So then we say, okay, next thing, if we don't have a rule, does u-substitution work? And in this case, it does. U-substitution is a good choice for this because we've got a function nested inside another function. So I would choose to let u be the inside function. Since I have this radical here, I could let u equal x squared or even negative 2x squared or just 2x squared, but then I would have to substitute again. The function that's nested inside this other function is this polynomial function. So that's probably going to be the best choice for u. So we'll let u equal 8 minus 2x squared. And then in order to complete the u-substitution and evaluate this integral to find area, we need to write everything up here entirely in terms of u. To do that, we need to compute du. That's just the derivative of this times dx. The derivative of a constant is 0. Then you bring this constant down. And then to evaluate the derivative of x to some power, remember this rule. The derivative of x to the n is n times x to the n minus 1. So you bring the power down and you multiply by x to the 1 less power. So we're going to bring the power down and multiply by x to the first, and then don't forget to multiply by dx. So du turns out to be equal to negative 4x dx. And we know that this will work, or we can determine whether this will work by looking at this and comparing it to this. We don't really have to worry about the negative 4. We can always adjust the constants, but we ask ourselves, do we have an x dx up here as a factor? And we do. There's the x and the dx. So that tells us the u-substitution will work. I don't need this negative 4 though. So I'm going to take this equation and solve for x dx by dividing both sides by negative 4. And of course, dividing by negative 4 is the same as multiplying by negative 1/4. So if negative 1/4 du turns out to be equal to x dx. And then I can write everything up here entirely in terms of u. So we're going to, or what we did was, we chose u to be the function nested inside of the other function. We computed du, and then we solve for whatever expression we actually have up here, which turns out to be x dx. We didn't need that constant. You're usually just adjusting the constant at that step. Okay, so that integral can now be rewritten in terms of u this way. This square root of 8 minus 2x squared times x dx can be written this way in terms of u. X dx turns out to be negative 1/4 of du. And remember, this is u So this expression here is not u, it's u under the square root. So it's the square root of u. So we've got the square root of u times -1/4 du. That is our integrand. And if you want, you can factor out the -1/4, and you can write that, rewrite that square root of u using exponent properties. Remember, the nth root of x to the m is x to the m over n. This is u to the 1/2 power, 1/2. And so now we have written our integral in terms of u. Okay, but we're not quite done yet. This was a definite integral. So that means when I write the integral in terms of u, in order to get from here to here, in order for these to be truly equal, I need new bounds. Right now, this is an antiderivative, and that's actually a value. That's a number. In order for this to equal that number, I need bounds for u. Here we still have the dx, so this is going from x equals 0 to x equals 2. Down here, we're going to need to know where u starts and where u stops. The way you find the new upper limit, that starting u value, or that final u value, and the new lower limit, that's our starting u value, is you take these x values and you just substitute them into your equation for u. So we had u equals 8 minus 2x squared. Oops. So I guess what I want now is I want to replace x with 0 and x with 2. So I want u evaluated at x equals 0, and I want u evaluated at x equals 2. X equals 0 was the lower bound, so this is our new lower bound for u. And x equals 2 was our new upper bound. So it's really simple. You just plug those in here, and this becomes, when you plug in 2 here, you get the new upper bound for u. When you plug in 0 here, you get the new lower bound for u. So this just gives us an 8. That's our new lower bound. So u goes from 8 to whatever this value is. 2 times 2 squared, that's 2 times 4. 2 times 4 is 8. 8 minus 8 is 0. So we have 8 as our lower bound and 0 as our upper bound. And then you just evaluate this. And because we've changed our limits of integration, we never have to go back to x. When you're doing definite integrals, when you do a u-substitution, after you change those bounds, you just evaluate the integral using the fundamental theorem and you're done. Now, there's another fact that we can use at this point in order to make our work just a little bit simpler. In Calculus 1, we learned this. The integral from a to b of f of x turns out to be -1 times the integral from b to a of f of x. So basically, you can switch those if you want. You can switch the limits of integration as long as you multiply by -1. So if you want that 0 to be down here and the 8 to be up there, and a lot of people do, you can flip them. You just have to multiply this -1/4 by -1 to get a positive 1/4. Okay, now we're ready. So you bring your 1/4 down, and then we just use the power rule. We add 1 to the exponent. 1 plus 1/2 is 1/2 plus 2/2, which is 3/2. And then we divide by the new exponent. Dividing by 3/2 is the same as multiplying by 2/3. And then you want to evaluate this expression from u equals 0 to u equals 8. And of course, you want to simplify if you can. So we've got 1/2 times 1/3, so we have a 1/6 here. And then we'll have 8 to the 3/2 power minus 0 to the 3/2 power, which we all know to be 0. Okay. Now, if you want to evaluate this, there are a couple of ways that you can do it. What I would recommend in this case is to take the square root first and then cube it. Because remember, a number to the m over n is the nth root of that number to the m, or it can be written this way. It's the nth root of the number, all raised to the m. So you can raise it to the power first and then take the root, or you can take the root and then raise it to the power. If I'm doing arithmetic, I almost always like to do this because taking that nth root is going to make it smaller, and then I'll be raising a smaller number to a power, which makes the arithmetic easier. So we're going to take 8 and take the square root of that, and then we're going to cube it. Oops, not 8, or not the square root of 2, the square root of 8. 8 is 4 times 2. Square root of 4 is 2. And so what we have here is 1/6 times 2 cubed times square root of 2 cubed. So it's square root of 2 times square root of 2 times square root of 2. So that ends up being an 8 times a 2. This is a 2. Square root of 2 times square root of 2 is 2. And then we've got an extra square root of 2 over there. So this 2 goes into that 6 3 times. And so we end up with 8 over 3 times the square root of 2. But that is the exact answer, and it's simplified, but it's not the answer that they want. They want an answer rounded to 4 decimal places. So we're going to say this is equal to 8 square roots of 2 over 3, which is approximately equal to this number. It's about 3.7712 square units. So it's a little bit hard to tell from my picture, but if this were drawn to scale, well, this little rectangular box has an area of 6 units because it's just 2 times 3, right? Well, it turns out the area under that curve, well, it's going to be less than that area of the rectangle. Turns out the area is actually approximately 3.7712, or exactly 8 times the square root of 2 over 3 square units.